Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 2016. Maximum difference between increasing elements. This problem is easy and it's a beginner friendly problem based out of arrays. And in this problem we'll be utilizing concepts which is similar to prefix. And it's a common pattern. You will also find it in a couple of other problems. And this question is asked in companies like Bloomberg, Cisco, Google, and Adobe. Let's have a look on the problem statement. In this problem, we are given 0 index integer array nums of size n, and we have to find the maximum difference between nums I and nums j. That is, this is how we have to find the difference. Firstly, we have to use the nums j and nums I, and I and j should be chosen in this pattern. First of all, choose I, then after that choose j, and both should be valid. And nums I should be less than nums j. Okay, let me make it clear to you. We are given integer array nums. So this nums array is given to us of size n. We have to choose two indices I and j, and both the indices should be valid. And indices are always in the range from 0 to n minus 1, or you can say less than n greater than equal to 0. This is given to us. And choose these I and j in such a way that value at I is less than value at j. This is another condition. And if these two conditions are met, then capture the value of value at j minus value at I. So this is going to be our candidate for the answer. So if value at I is less than value at j, and I am doing value at j minus value of I, taking the difference, this difference, then whatever is the maximum difference we can get out of this array, that is something we have to return. Now this is the problem statement, and here if we try to have a look on this example, if I choose this as I and this as j, then what is the difference? Difference is 5 minus 1, which is 4. Let's say if I have chosen this 4 as my j pointer, j index, then the difference is 4 minus 1, which is 3. But we are concerned about maximum difference. So in this case, I and j are well suited at these two positions. So answer is 4. So 4 is going to be something I'm returning from it. And if there is no such I and j, it means we are not able to find a pair. Let's say array elements are something like this: 1, 4, 3, 2, 1, 4, 3, 2, 1. In this case, we cannot find a valid pair because there is no value at I which is less than value at j. Okay. Now I hope the problem statement is clear to you all, and we will try to see how we can solve it. Nums array is 7, 1, 5, 4. Let me take the same array: 7, 1, 5, 4. I have to choose two valid indices I and j such that value at I is less than value at j. And in that case, if this valid combination exists, then whatever is the value of j minus I, value at j, if I'm using this big brackets, it means that value at that particular index, then this value is the candidate, and whatever is the maximum candidate, we have to choose that. Okay. For all I, we have to choose for all j. It's totally up to you how we can do it. Let's have a discussion over the brute force. Brute force, we are choosing pairs and then checking whether the pair is valid or not. If it is valid, then capture the answer. So to choose all the pairs, we can use two nested loops to check all the pairs. For I is equal to this valid range 0 to n, less than n, or you can say n minus 1. Then for every I, what is the valid j? J is something greater than I. So j, if I just start with I plus 1 and I'm checking all the valid values of j less than n. Let's here also write less than n. So these are two nested loops. Nested loops I'm using to find out all the pairs. And if all the pairs, now this is valid pair. And for valid pair, the condition is pretty straightforward. J should be greater than I, or I should be greater than less than j. Let me write it the same way it is given in the problem statement. I is less than j. It means it is valid. If it is valid, then capture the result. And how I'm going to capture? I'm going to capture the delta difference. If this difference is greater than the previously captured answer, then update it. Now this is going to be the brute force, and in this brute force, as we are using two nested loops, the time complexity is going to be order of n square. But here we have to improve it to the linear time, and for linear time what we can do? The optimized approach. In the optimized approach, I'm going to follow a standard pattern among couple of array problems, which is like, what is the maximum value if I just fix this value of j? See, in this case we have to find this pair. If I just fix this pair, what I need to find is valid value of I. Let's say this is my j. Now what can be the valid value of I? From this range, whatever is the least value, whatever is the minimum value, and that should also be less than j. So that is going to be my valid I. If there is no valid I, then there is no answer from that j. So in this case there is no valid I. Now if I try to move this j pointer here, this is j, and now what is the valid value of I? This is the valid value of I, because it is minimum and it is also less than value of j. So if we are going to find out this valid value of I by running a loop again every single time, then it is also becoming nested loops. But what we are going to do in this case is, we are going to think in a smarter way, that let's say when I was at 5, I have already seen whatever is the minimum value among this range, that is 1. But now when my j pointer is at 4, so what is the minimum value we need to find from this range? This range we need to know the minimum value, and from this range we already know the minimum value. There is one more element. So if I just directly compare this minimum value so far with this value, then I will be able to get minimum value before j in order of 1 time. In short, what I am doing is, I am doing something similar to running sum in prefix sum category, or you can also call it prefix, or in simple terms, we are doing it while doing the iteration. While we are traversing, we are keeping track of the minimum so far, minimum element so far. So now if I just use this approach, what will be my initialization? Initialization mean before we get started with the algorithm, what should be the state of all the pointers and other arrays. So minimum so far is something, let's say I have taken the minimum so far is first element. This is the array given to us. Minimum element so far is equal to 7, which is element at 0. What if there is no element in this array? For that we have to check for the constraints, but in the constraints there should be at least one element. No, not this one. At least 2 elements are there. It means nothing. There is at least some elements in the array. So minimum so far I can initialize to the first element, and after that if I have to form a pair, I can start my iteration from second pointer onwards. Second pointer onwards I will start my iteration, and that pointer will behave like I, and this minimum so far will behave like a valid j, or the best j so far. So minimum so far is 0, and what is my answer? See, answer is something, if I am not able to capture anything, then the default value is -1. It is also given in the problem statement, written -1 if you are not able to find a valid pair. Okay, these are the valid pairs. Now I have to do the iteration, and what is this iteration? For j is equal to 1, j less than n, and j++. So j pointer I am taking for the whole loop, and for every single value of j I am checking the minimum so far. So here value at I is minimum so far and value at j is seen along the loop. Now I need to see whether this I and j are forming a valid pair. They will be forming a valid pair if this value is less than j. So if minimum so far is less than the value at j, now this is a valid pair. If this is a valid pair, it means this difference between j and minimum so far can be my candidate, and if it is a candidate, it can be the better candidate than the previous captured one. So answer is equal to minimum of answer comma value at j minus minimum so far. So I have captured it. If it is a valid pair, just capture it and keep on capturing it. Now let's say when you are done capturing the answer for this j, maybe in the next iteration you are going to increment j, and this current j will be the part of the range for I. So here we also need to see the minimum so far. So minimum so far is equal to minimum of current minimum so far comma whatever is the value of j. So we are keeping the minimum so far updated along the loop, and we are capturing the answer if we are getting a better candidate, and we are doing iteration, or we are just traversing the whole array to get the answer. Now let me do the dry run over the sample example. If I just remove all of these items and I take the same array 7154. 7154. What is the initialization state? Minimum so far is equal to element at 0, 7. And what is the answer? Answer is -1. And what is the value of j? J is here. And j is currently pointing to 0, 0, 1, 2, 3. So j is not going to point to 0, j will be pointing to 1, because I am starting the loop from 1. Okay, now let's see if I am getting the answer. Best or minimum value in this range is minimum so far. So minimum so far, if minimum so far is less than the current value of j, then it is a valid pair. But here it is not a valid pair, so just move ahead and capture the minimum so far. Okay, so now minimum so far will be updated to 1 and the j pointer will be updated to the next one. Okay, now this is the case. Here this minimum so far is going to hold the minimum value from the previous range, so that will work as a valid I. So minimum so far is 1 and j is 5. So if it is a valid pair, then capture j minus minimum so far, and j minus min so far is j minus 1, which is 4. Capture 4 means if it is greater than, answer is always maximum. So why I have written minimum here? Maximize the answer. We have to maximize the answer and keeping the tracking the minimum element, maximum difference. So 4 is a valid candidate and it is a better candidate, so they update the answer. Updating the answer and update the minimum so far. Minimum will remain the same and now j will be incremented. Okay, now this is the current state. And at this iteration, what is the minimum among this range? This minimum so far is going to hold that. And what is the j value? J value is 4. So 4 minus 1, which is equal to 3. No, this is not going to update the answer in this case, because we already have a better answer, that is 4. So we'll just move ahead, update, and minimum so far is also not going to be updated. So now the j value is going to be here. So if it is out of this loop, we are stopping here, and the maximum answer that we can get is 4. So that is our answer. So that's all. So this is how we did one traversal to solve this problem in order of n time. So what we did here is traversal, keeping track of the prefix or running some like similar concept, and we are able to do it in order of n time. And what about the space? We are not taking any extra space. This is These are two variables I have taken. So order of n time, order of one space, and this is the whole algorithm. And if you just write it and try to submit it, it should work well. Now let's write the code for our approach. And here what we decided that we will be keeping track of minimum so far, and that is going to behave like a valid value of nums of I, which is the least value among the previous elements. So integer minimum so far, let's say I have taken nums of 0 as the minimum so far, because nums array size is going to be greater than 2, so definitely it is going to have some element. And answer is by default initialized with -1, it's a default value. And I'm going to iterate over the array starting from j equal to 1, j less than nums dot length, and j plus plus. Min so far is going to have a valid value of nums of I, and nums of j we already have with this iteration. I also need to see whether this pair is valid or not. If this pair is valid, then just capture it. And what is this nums of I? Nums of I is minimum so far less than nums of I. And here if it is valid, just update the answer. Answer is equal to math dot max answer comma new candidate for the answer, and new candidate for the answer is nums of j minus minimum so far. Now I have updated the answer, and I will keep the minimum so far updated for the next iteration. Math dot min minimum so far, and then for the next iteration it is going to be compared with nums of j. Minimum so far is updated for the next iteration, and we'll just keep on capturing all the valid pairs. Whenever we are getting a valid pair, we have to capture it. So this condition is important, and in the end whatever is the best value we have captured, otherwise the default value we have to return. Let me check over sample test cases. All the sample test cases are passed. I'm submitting the problem. It got submitted successfully. I hope you understood the approach. It's a beginner friendly good problem on prefix, and in case you get any doubt, you just comment down below and let me know if you have any other questions as well. Thank you guys. Thanks for watching. Bye bye.